All right, so let's talk about this ellipse. You might say, ellipse? This is not in the right form. What are you talking about? Well, it's time for us to put this into the correct form. Now, for us to do this, we're going to have to do some completing the square. Just like we did with circles, we want to rearrange the terms, putting the x's together, the y's together, and kicking that pesky constant to the other side. So, you go over there. And I'm going to rearrange these guys so I have 25x squared plus 50x, leave some space, and then we do plus 16y squared plus 192y equals negative 201. Now, normally when we were completing the square and we had circles, we would have just 1x squared and 1y squared. So since we don't have that, we're going to have to do some factoring first. So let's factor out the 25 here, so we have just 1x squared. And also factor that out of the x term here, so we have 2x. Again, leave some space. Plus, now let's factor out the 16, so we have y squared. And when we take 16 out of 192, if I'm doing the math correctly, that would give us 12, so plus 12y, again, leave some space, and it still equals the negative 201. We didn't do anything with that. All right, now here's where things get kind of tricky. Our goal is to have this as 25 times something squared with an x in it, and then we'll have this 16 as something squared with a y in it. All right, so here's what we're going to do. We're going to complete the square, but you got to watch where things go. So first of all, when we complete the square, we will look at this middle coefficient. We're going to do half of that. So half of 2 is plus 1. And then we square that, and we have, again, plus 1. Now, you see that I have there in red that I added 1, so that changes the problem, unless I also change the other side in the same way. But I can't just add 1, because I added this 1 here inside of a set of parentheses that had a 25 on the outside. So I'm not really adding 1, I'm adding 1 times 25. So I need to add 25 over here. Now when I look at the y's, half of 12 is 6. And 6 squared is 36. And so now I have to add not 36, but 16 times 36. So that's, what, 576? I think that sounds about right. And let me erase that negative 201 because that is now going to be different. And it's going to be all of this combined. So let's see, that gives me 400. All right, so we're getting closer to being in the form of an ellipse. So what we need to do is we need to make sure that we have just a 1 on the right side of the equation. So I'm going to divide everything here by 400. Divide this joker by 400 and this guy as well. And then I simplify each of these. So I have x plus 1, quantity squared, over, now when we simplify 25 and 400, 25 goes into both of them, so you get 1 in the numerator, and we get 16 in the denominator. And over here, we have y plus 6 squared. 16 goes into 400, 25 times, and then we have is equal to 1. All right, so from here, we can answer all the other questions that we need to answer, right? So we can just forget about all the other stuff and just say, what is the center? So the center would be the ordered pair, -1, -6. And let's just draw a quick picture. Here is my center at -1, -6. From here, my a value is going to be the square root of 16, so that's 4. And my b value is 5. So since the value underneath the y is larger, I'm going to be stretched more in the y direction. So it's going to be 5 units going up. So from here to here, 5 units going down. And then left and right will only be 4 units. So it's 4 units from here to here. And then my graph. Again, if you have a graphing grid, it makes things a lot easier. But again, not every number is going to be nice and pretty. Again, this is just to give us an idea about what's going on. Now we'd like to talk about the foci next, so we need to find out what c is. So c squared is going to be the difference between 25 and 16. C squared equals 9, which means that c equals 3. So since we're stretched in the y direction, that means the c is going to be up and down from my center. So the foci will be going up and down 3 from here. So if I go up 3, that's -3. If I go down 3, that's -9. And while we're doing that, we then switch over to the vertices. And the vertices are going to be, since you've got a 5 here, they're going to be plus and minus 5 on the y. So if I do plus 5, we get -1. If I do minus 5, I get -11. So these will be the two vertices, which then leads me to the length of the major axis. Again, look at this, 5. You're going 5 up, 5 down, so that total length is 10. And the length of the minor axis is going to be double the other value, so double 4 is 8. And now let's talk about the endpoints of the minor axis. All right, so the minor endpoints are going to be left and right of center by 4 units. So if I go left of here by 4 units, that is -5 and -6. If I go to the right 4 units, -1 plus 4 is 3, so 3, -6. And then my domain. So my domain, as I go from left to right, since that's along the minor axis, from left to right, those guys right there, so -5 to 3. And then my range is going to be along the major axis, which is going to be my vertices. They go from -11 to -1. So -11 up to -1. So for a problem like this, complete the square, and we're going to be in good shape. All right, so let's try another one. One just as crazy as what we just did. So we have 2x squared plus 25y squared minus 32x plus 350y plus 1,253. Again, we're not allowed to freak out about numbers. Numbers are just numbers. Let's see. Do I have... Oh, here it is. So I've got my little basic calculator right here, and there's nothing that I can't do on this for the problem. So I should be in good shape. First, we're going to move that guy to the other side. He's gone. Rearranging, we have 2x squared with -32x, leave some space, plus 25y squared plus 350y, leave space, equals -1,253. As we did in the previous problem, we need to factor out this leading coefficient. So factor out the 2. We have x squared minus 16x, leave some space. We factor out the 25. All right, so if I factor 25 out of 350, that should give me 14, but let me just... Does this thing work? Oh, there it is. All right, so if I do 350 divided by 25, it would be helpful if I actually divided by 25 and not 24. So 14. I already knew that, but sometimes I feel like I need a double check. So 14y, leave some space, equals -1,253. All right. So now I am trying to complete the square for each of these. let's see what it's going to equal. All right, so first I do half of negative 16, which gives me negative 8. And I square negative 8, and that goes here as a plus 64. And as we showed above, I can't just add 64 to the other side. It's 64 times the 2, right? So that means I have to add 128. Now we move on to this guy right here. So half of 14 is 7, so plus 7. 7 squared is 49. All right, so if I do the math there, that should be 1225. Again, let me just check real quick. So 25 times 49, 1225. All right, so I need to add 1225. You might say, where to get the 1225 from? Because I didn't just add 49. I added 25 times 49. All right, so when I add everything on the other side, I've got 1225 plus 128 minus 1,253. And I get a nice, tidy 100. Isn't that nice? But we were supposed to have a 1 there. So we'll now take this, divide everything by 100, and simplify. All right, so that gives me x minus 8 quantity squared over 50 plus y plus 7 quantity squared over 4, 25 and 100 reduced to 1/4, is equal to 1. So once we're here, we don't really need to worry about all the stuff that came before that. From this, we can answer all those questions about the ellipse. The center is 8, -7. The a and b values, so let's see, so that means a is the square root of 50, which reduces to 5 square roots of 2. And here, that means b is the square root of 4, which is just 2. My center, again, somewhere out here, doesn't matter how big the numbers are, you can just plot a point, so 8, -7. Since the value underneath the x is larger than the one underneath the y, I'm stretched more in an x direction. And that is going to be a distance of 5 square roots of 2 in either direction. So I'll have my endpoints here and here. And then because of my b values, b is 2, it's underneath the y, I'd be going up 2 units and down 2 units. And then from here, I should be able to have my nice ellipse. Again, not exact, but it gives us an idea about where things are. We want to find the foci, so we need to find the c. So we start off with c squared. C squared is the difference between these guys, so 50 minus 4 is 46, and c is the square root of 46. Not a pretty number. It doesn't reduce, so we just have to leave it as it is. But that c value is going to put our foci over here and here, square root of 46 units away from the center. So my foci, what's changing because I'm stretched in the x direction will be the x coordinate for the foci. So it's going to be 8 plus or minus the square root of 46, comma -7. And then my vertices, so those vertices are along the major axis, which is parallel to the x-axis. And that total distance you see right here is 5 square roots of 2. So that means we're doing 8 plus or minus 5 square roots of 2, comma -7. The length of the major axis is double this guy. So it's going to be 10 square roots of 2. the length of the minor axis is going to be this total distance here. In other words, double that guy, so 2 times 2 is 4. The endpoints of the minor axis. So since it's a nice value of 2, we're not just going to say plus or minus 2. We actually need to work that out. So if I do plus or minus 2 to the y value, because we're going up and down 2, that's going to be 8 plus 2 is negative 5, and minus 2 would make that negative 9. So those would be those endpoints. And then I think that's almost it. We just need to talk about the domain and the range. So my domain, the change here is along the major axis, so we can go to those vertices, and you see it's 8 plus or minus 5 square roots of 2. So on the left, it's coming from 8 minus 5 square roots of 2 to the right at 8 plus 5 square roots of 2. And then for the range, you're going along these endpoints of the minor axis. So from negative 9 to negative 5. And we've answered all that we need to answer for that. So again, it's all about completing that square like we did up here. And as we did in the first example, complete the square, see what the new form is going to look like. And then from there, it's just like all the other problems that we've already done. So watch your signs and make sure you know how to complete the square.